Good afternoon, guys. My name is Ismail Mashoud, a student of Federal University of Technology, Akure. This afternoon, I'll be taking you through a topic we call flexible manufacturing system in IP 507. What do we mean by flexible manufacturing system? Flexible manufacturing system is a highly automated group of technology machine cells consisting of a group of processing workstations interconnected by an automated material handling and storage system and controlled by a distributed computer system. Now, in order to really understand what we mean by this particular topic called flexible manufacturing system, let me try to break it down by highlighting the necessary stuff we need to know there. So we say a flexible manufacturing system is a highly automated group of technology machine cells. This is really needed. And what it must consist of what? Consist of group of processing workstations. That's number two. Interconnected by what? Material handling and what? And storage system. And then the last one, which is the what? It must be controlled by what? By computer distributed system. Let's take an example for that. So guys, I will be taking you through the calculation now, while we also have to explain some things. But before then, let's look at these parameters, this particular formula. So in FMC, you can be told to calculate different parameters in the FMC. So number one is the total operating time. You know, I said earlier that each machine in this FMC, we have what? Different machines that are working on a what particular on different products. So we can be told to calculate the total operating time for what? For each workstation, rather, for each workstation, which is the what? Which can be combination of what? Several set of machines that are working on what? On different operations or a single operation. So we can be able to calculate the what? Total operating time. So if we are able to calculate the total operating time, the formula is what? The part mix times what? Times the operating time of each machine in the workstation. The operating time of each machine, and then times the what? Times the operation frequency. That's if you were given. So if you were not given, we assume it is what? It is 1. Now we can also be told that is for the what? For the machines. But you know, we also have material handling system in this FMC. So now to calculate the total operating time, that it will take total operating time it will take the material handling system in the whole manufacturing. So we use the formula NT times what? Times mean transport time. So this NT can be gotten by using this particular formula as well, which is what? The server, number of server times what? Times the part mix times what? Times operation frequency. Number of server is like, let's say in a particular operation manufacturing system, flexible manufacturing system, we have drilling machine, like I said the other time, we have milling machine, we have um mini machine. So we can have different types of different mini machines, like we have up to 2, we can have up to 3. So the number of that machines is what we call the number of server. So in a situation where we have 3 mini machines, it means we have what? We have 3 servers. Also the part mix, the part mix, this is the proportion. Let's want to manufacture products, we want to manufacture product A. What is the percentage, or let me say the proportion of that what? The proportion of that product A in the whole manufacturing system. This PJ, we can check down here. This PJ is what? Is the proportion of product J. What this means is that, let's say we are manufacturing 3 products, product A, product B, product C. Each of these products has a particular proportion, which is in ratio of what? Between 0 and 1, or it might be in what? In percentage. So let's say product A has 0.2 part mix. It means 20%. 20%, the machine, the entire manufacturing system is working on what? 20% of this particular product. Let's say product B has 0.3, that is 30% of this particular product, and product C has, let's say, 50%, 0.5. That means it takes 50% of the whole what? Of the whole production system with the product. So that's what we mean by what? Part mix. And also we have TIJ, which is the what? Which is the processing time of product J. So let's say product A, as I was saying, let's say it has the time it will take a machine to manufacture what? To manufacture that particular product. And also we have the operation frequency, which might be given and it might not be given. So if it is given, we use it, but if it is not given, we take it as what? As 1. So let's solve one example for this, for us to understand this flexible manufacturing system. So in the question, we can see the question on the screen, right? So we are told to find the maximum production rate of the FMS, the utilization of each machine in the system, and the average utilization of the system. So let me read out the question. A flexible manufacturing system consists of 3 stations. That is, it has what? 3 stations, like 3 workstations. I've explained what station means the other time. 3 workstations, and then what? Plus a load and unload station. It also has what? Load and unload station. That's another additional station. The load and unload is just like the what? The load station is where the input is being coming in, while the unload station is the one that will go, like the packaging system, that will be moving the what? The product, the entire product from the what? From the production system. So they group both of them as what? As just one station. So we have another one station now, which is what? The load and unload station. So making what? How many stations we have in together? So we have 4 stations. Yes, I forgot to say this. Flexible manufacturing system can be grouped into 3. We have 3 categories. Sorry for that. So we have what? The FMS. FMS, which is the flexible manufacturing system. This is when we have what? 4 or more workstations. When we have 4 or more workstations, we call it what? We call it flexible manufacturing system. But when we have 2 or 3 workstations, we have 2 or 3 workstations, we call it flexible manufacturing cell. 2 or what? Or 3 workstations, we call it flexible manufacturing system. And we also have single manufacturing cell, which is the what? Which is when we have just one workstation. And we know what workstation means, right? So now that's that about that. Let's quickly solve the question. So which means, okay, before that, which means this particular question is what is being, which type of the what? The FMS do you have a, which is what? The flexible manufacturing manufacturing system. Like, so which means which type of system do we have for this particular problem, which is what? Which means which type of so having understand this, which type of system do we have in this particular question? So we say it is what? Flexible manufacturing system. Of course, you can see that we have 3 stations here, 1 station which is 4 station. We have 4 stations, and when we have 4 stations, we have what? 4. We call it what? Flexible manufacturing system. We can also have FMC and SMC. So when station 1 loads and unload parts using 2 stations, material handling workers. Station 1 loads and unload parts using 2 servers, rather, material handling workers. Station 2 perform horizontal milling operation for station 1. Station 1, which is what? Load and unload. Load and unload station. So they said it has what? 2 servers. So I've explained what servers means as well. Let's say we have mini machine. We have 2 mini machines. That's 2 servers. 3 mini machine, 3 servers. So the station 2 perform horizontal mini machine. Station 2 horizontal what? Mini machine. So it has what? Mini machine with 2 servers. It has 2 servers as well. 2 servers. Station 3 perform what? Vertical mini operation, and it has what? Vertical mini machine. It consists of vertical mini machine. In station 3 we have vertical mini machine in station 3, and it's what? It is it has 3 servers. So CNC vertical mini machine, the machine are connected, listen to this carefully, Okay, so station 4 perform draining operation with 2 servers. We also have station 4 draining operation, which is the draining machine, right? With what? With 4 servers. Perform draining with 2 servers, rather. With 2 servers. So those are the servers we have. You know, we have 3 stations and what? 1 workstation. That's 4 stations. So now the machine are connected by a part handling system. Listen to this carefully. By a part handling system. This part handling system is what we call the what? The material handling system. That is the material that links all these stations together, that transports the product from one station to another station. So that is the what? The material handling system. So they said it's the machines are connected by a part handling system that has 3 work carriers, rather. It has 3 work carriers. In the case of what? The material handling system, we use work carriers and not server. So for the material handling system, it has what? 3 carriers. That is the carrier that transporting the product from one station to another station. So we don't call it server in that case. So and the mean transport time of what? Of 3.5 minutes. They've given us the mean transport time. That is the time it takes the material system to complete one cycle. The FMC produce 4 parts. It's now produced. Now to the question, it produce what? 4 parts, which is part A, part B, part C, part D. This part A, part C, part A, part B, part C, and part D, you can link it to that. Let me say somewhere like something like, let me say in a company manufacturing a car. So we can manufacture, let's say maybe this is Formatic Benz, this is Formatic Benz, CLA class, and the likes. So 4 parts like that. They are manufacturing four parts. So the parts are now represented as what? As A, B, C, D, instead of being represented with car as the example I brought up. So we have 4 parts now, as you can see on the screen as well. Part A, part B, part C, and part D. So we've been given the part mix of each part of each product, rather. The description, like which type of operation is being performed on it, we've been given, and what the station, which type of the station, we've listed the station out already, and then what the processing time it takes. So for now, let's move to the first question. For the first question, we are going to find the maximum production rate of the system. For the maximum production rate of the system, we know we have the formula. Maximum production rate, you can check the formula if you can't really remember. Maximum production rate to be equals to what? 1 over bottleneck. You don't need to really memorize this formula step by step. We certainly remember. So what is the bottleneck? How do we get the bottleneck? We need to get, the way we get the bottleneck is by what? We find the what? WLI ratio. We need to find WLI ratio. That is the what? The total operating time. You can check the formula. The total operating time and what? The total operating time over the number of server. That's the WLI ratio. That will give us the what? The machine. That will give us the machine with the highest what? That took the highest time. Like I said, the bottleneck is the slowest part of the what? Of the system. So now for us to know the slowest part of the system, we need to identify the machine that will take the what? The maximum time. So in order for us to know that, we use WLI ratio. We use WLI ratio over SI. So the one that is the highest here will be the one with the what? With the bottleneck. And once we can find that, we can just what? It will be easier for us to get our what? The maximum production rate. So which means we need to find what? WLI ratio and what? And the SI. We need to find the WLI and what? And the SI, which is the total operating time for each what? For each machine and what? And the number of servers. So now let's find that. In order for us to get the maximum production rate, the maximum production rate is what? Maximum production rate is 1 over what? The bottleneck. I know what the bottleneck is. So now for us to get the bottleneck, we need to know the what? The WLI ratio. That is WLI over what? Over SI. Now for us to get this, we need to find this and what? And the SI as well. So let's quickly do that. I've given the formula at the beginning of the course as what? As WLI equals to what? Summation of what? Summation of the part mix times what? Times total operating time times what? Times the operating frequency. That's if we were given. So now, for the first machine, let's say the machine A is what? Is for the first machine we have load and unload, load and unload. This number of 5. Let's load and unload be 1. Load and what? Unload workstation rather, not machine. Load and unload workstation, we signify it as what? As 1. Then the horizontal mini machine, horizontal mini machine, we represent that one with what? With 2. The vertical mini machine, let's represent that one with 3. And the what? Donor machine with what? With 4. I think that's all. The material handling system, yes, that's all. That's all for the what? For the machine. So load and unload is 1, horizontal menu is 2, vertical menu is 3, and drain is what? Is 4. So for the first one, which is the first machine, which is load and unload, first workstation, load and unload, WLI 1 will be what? Will be the part mix of what? Of load and unload. Let's check the question. Let's check the table rather. So for the load and unload, we can see the load station has what? Processing time of 4 minutes, and the unload station has what? Processing time of what? Of 3 minutes. They group both together, so we need to add what? Their operating time. So which means for WLI 1, which is load and unload, we have what? 3 plus 4. That's their processing time. Times what? Times this is the processing time times the part mix rather. Let's start from the part mix. So their part mix is what? For that particular product A. For product A, the part mix is what? Is 0.2 times what? Times the operating time. The operating time is what? 4 plus 3. That is the load one and the unload one. Times what? The operation frequency, which is the 1. We are giving operation frequency to be 1 in the question. Let's go back to the question. You see something like Fijk, which is equals to 1.0. So let me quickly write down one here. Fij equals to what? 1.0. So this is for product A. For product B plus, you don't need to write this, is just for explanation. You don't need to write this thing there. We want to find total operating time for the whole product, not for just product A. So we need to do it for product A, for product B, for product C, and for what? Product D, and then sum them together. That's how we know what the total operating time for what? For that particular what? That particular workstation. So now plus what? Let's go to product B. The part mix is 0.2 times what? The operating time is also 4 plus 3, which is 7, times what? Times the operating frequency is 1.0. The operating frequency is general to the whole workstation. So we use what? Is that 1.0 plus what? As we have been given in the question, plus that of C, which is 0.25 times what? That is operating time, which is 4 plus 3 times 1.0, plus that of D, which is 0.35 times what? Times 4 plus 3 as well, times 1.0. So if you sum everything together, I think everything is equals to what? It's equals to 7.0 minutes. We do the same thing for the what? For the horizontal mini what? Machine, or the horizontal mini workstation. So WLI 2 equals to what? Equals to, for the horizontal mini, we can see there under the description, horizontal mini is number 2. So it has what? The station is 2, and the processing time is what? Is 15. The part mix for that horizontal, the part mix for all the what? For all the workstation in part A is what? Is 0.2. So that would be 0.2 for A times what? Times the operating time, which is 15, times what? 1.0, plus what? We go to B, plus that of B, which is 0.2, 0.2 as well, times what? Times horizontal mean is 16, times what? Times 1, plus that of C, 0.25, times what? Times 2, times what? Times 1, plus, okay, I think that's all. So we sum everything together, we see, we get it to be what? To be equals to 8.7 minutes. So guys, in order to get WL3, that is the total operating time for what? For vertical mean, we do the same thing we've been doing by saying what? The total and the part mix of what? Of, this should be 0.2, what was it? 0.2, we can put Zen here, because this is the part mix, this is the operating time, this is the what? Operation frequency. So now to get the the WL3, that is total operating time for what? For vertical mean, we do the same thing we've been doing by saying what? The part mix of product A, which is 0.2, times what? Times the operating time for vertical mean in product A. So we check that, we see under description, vertical mean, it takes vertical mean 14 minutes to what? To work on product A, which is just 14 times what? Times the what? The operation frequency. Then we move to what? We move to product B. Product B is 0.2 times what? Times vertical mean. It takes vertical mean 11 minutes to work on what? To work on product B as well, times 1, plus 0.25 times what? For product C, 0.25. There is no vertical mean in product C, just like we don't have horizontal mean in product, just like we don't have horizontal mean in product D as well. For this H mean, we don't have horizontal mean. That's why we have 1, 2, 3, not for the whole stuff. So for the WL3, which is total operating time for what? For vertical mean, we have it in what? Product A, product B, product what? And product C. We don't have it for D. So this is 0.25 times what? Times for vertical mean. We don't even have it for third. We only have it for what? For the fourth one. Vertical mean, that will be 0.35 times what? Times 0.35 times 18. 0.35 times 0.35 times 18, right, times 1. So we sum everything together, we get it to be what? To be 11.3 minutes. Okay, for the last station, which is WL4, that is for drill. Let's do it for that one as well. So, and let's take care of this particular place. So for this drilling operation, for this drilling workstation, we have what? 0.2 for part A, 0.2 times what? Times the processing time. Let's take the processing time. The processing time is 13 times 1 plus that of B. For product B, we have two drilling what? Drill workstation in product B. You can see 2 is drill and 5 is what? Is also drill as well. So we need to add the time together. We need to add the time together because they are the same machine, just that what? They are placed in different sections of the production cycle. So we need to add the time together for us to get what? The total operating time for what? For drilling machine, for the drill workstation. So the first one is um the first one is 12 and second one is 17. That will be what? Okay, firstly the part mix, which is 0.2 times what? Times 12 plus what? Plus 17. That is total operating time for what? The total operating time for what? For drill in product what? For product B. So times 1 plus, we move to product C. Product C, there is drill in product C as well, which is, but the part mix is what? 0.25 times what? Times, the time is 9 minutes and the operating frequency is 1. Plus the last one, which is the product D. For product D, the part mix is 0.35 times what? Times the operating time 8 times 1. Sum everything together and you will get um 13.45 minutes. So 30.45 minutes. Have you done this? Is that all? No, that's not all. Because we need to calculate the total operating time for the material handling system as well. We need to calculate the what? The total operating time for the material handling system, which is the what? The the material handling system there. How do we do that? I've given us the formula to be what? For the material handling system, you say the formula is what? The mean transport time, the time it takes the what? The material handling system to complete one cycle, right? Times what? Times the mean, sorry, the number of cycle for the material handling system times what? That's times mean operating time. That is the time it takes to complete one cycle. That's how we get the what? The total operating time for the what? For the material handling system. So, and that will be what? We'll be given the mean operating time, which is mu t to be equal to 3.5. We need to find nt. And we said nt is equals to what? Nt is equals to summation of what? Si times what? Times pj times what? Times the operational frequency if you have. And if you don't have, we take it as what? We take it as 1. So what do we mean by the SIA? The SIA is the, let's say I forgot to explain that. The SIA is the what? The number of server for each part. Let's look at the table. For part A, right, we have, let's take for part A, how many server, like how many machines, let's put it that way in a simplified term. How many machines work on what? On product A. So we check it there, we see we have load and unload workstation. We have load and unload workstation. We have H mean, we have a V mean, and we have D. That's what? 4 servers. That's what we mean by what? By SI. The SI there is the what? Number of what? Number of server for each product. So now for product B, I will quickly explain so I can write it at the same time, write everything together at once. So for product B, how many server do you have here? Load and unload is 1 server. We've been told from the beginning of the question. Load and unload is 1 server. We have drill, that is 2. H mean 3. V mean 4. Another drill 5. We are not going to add the drill together in this case because we need the time. They both work what differently. One is working here at one corner. Let's say one working at one corner, another one is working at another corner. We can't say because they are the same thing, we just take one and then leave the rest. So we consider both. So which means now we have what? 5 what? Servers. 5 server, which is SI. This server is different from, let's call it SJ. It's different from the server we've been talking about since. The server we've been talking about since is the one in the question. Have we talked? Yes, we've not even talked about that one yet. We are given one server in the question. The server in the question. I'm coming. So for the material system, we need to know the total operating time as well. And we said for us to know the total operating time, we need to know the number of cycle and what the main operating time. That is number of cycle. It takes the what? The material system. The number of cycle it takes the material handling system, and the what? And the main transport time. We've been given the mean transport time to be 3.5, but then we're not given the what? The number of cycle, which is nt. So how do you find the number of cycle? We'll be given the question of written this at the beginning of the question of the solution, that nt, which is number of cycles, is equal to summation of si what times pj times fij. So sorry, in order for us not to get confused, let's change this to wi, not si. This one I said that we understand, this one I said that later in the question. So guys, we've obtained the WLI one, the total operating time for all the workstations, which is the load from load to what to drain. But is that all? No, that's not all. Because material handling system is also part of the system. And for this system, we need to find the total operating time for it as well. We need to find the total operating time for the material handling system. And the formula has been given from the beginning of this solution that for the material handling system, the total operating time is what? The cycle, number of cycle times what? Times the mean transport time. The mean transport time has been given in the question. Let's check the question. It has been given in the question as what? As 3.5. So what else we need to find is what? The number of cycle, which is nt. Number of cycle is what? WLI, summation of what? WI times what? Times pj times what? Times fij. I change this to WLI because in order to get confused, initially I use si. That si is the number of server. So in this case, this is the what? Let's say the number of WLI here represent the what? The number of what? Number of workstation for each what? For each product. So WIA means what? Number of workstation for each what? For each product. Let's quickly check the table. We see that for product A, we have how many machines there in order to. Okay, for product A, we have how many workstations there? We have what? We have 4 workstations there, right? Let me use this to number of workstation, what we call it, the machine. So I don't want us to get confused, that's why I put slash machine. So guys, we've obtained how to get the operating time for what? For product A, for load and unload, up to what? Up to drain workstation. So, but is that all? That's not all, because we need what? We need to find the material handling system is also part of the what? Part of the system. So we need to find the total operating system, total operating time for the material handling system as well. We need to find the total operating system for the material, total operating time for the material handling system as well. But how do we get that? Now the formula is equal. I've given the formula from the beginning of this solution to be what? Nt times what? Mu t. Why nt is the what? The number of cycle. The number of cycle, and mu t is what? Mu t is the what? The mean transport time. The mean transport time has been given in question to be 3.5. You can check our question. It has been given to be 3.5. So we need to calculate what? The number of cycle. And number of cycle is what? Is wi times pj times fij. I change this to wi in order for us not to get confused. There's si I used in the beginning represent the number of server. But here, wi represent the what? Number of workstation slash, let me say, machine for what? For each product. Let's quickly go to the table. For product A, we see that we have load and unload, we have hmin, we have vmin, we have dreaming. These are the number of stations we are talking about. The number of workstation that works on what? On product A. So for product A now, we have what? We have 4 workstations. That will be wi for product A will be what? Will be 4. Because we have load and unload is 1, hmin is 2, vmin 3, drill is 4. Right? Let's go to product B, because we need to really explain something there. For product B, we have load and unload, that is 1, drill, that is 2, hmin, that is 3, vmin, that is 4, drill, that is 5. We need to count that drill again. This is why I said we need to count that drill again, is because this is workstation. So for product B now, we have what? We have 5 drill. We have 5 what? 5 workstation that work on it. So that's that. We use that to calculate the nt now. So nt will be equals to what? The wi for product A. Product A has what? 4 times what? Part means for product A 0.2 times operating frequency, frequency, yes, 1, plus what? We move to product B. Product B has what? 5, like I explained, times the operating time is what? The operating time is, the part mix is 0.2 as well, times 1. For product C, it has how many station? Load, hmin, drill, and unload. Load and unload are 1, H mean 2, then breathe 3. So that is 3 into 0.25 into 1. Then plus for 3, it is for product D, it is 3 as well. That will be 3 into 0.35 into 1. Calculate everything and we get it to be equals to what? To be equals to 3.6. So now we know this now. 3.6 means we know this now. We need to get our what? WLM, which is the what? Total operating time for the material handling system. Total operating time for the material handling system now will now be equals to 3.6 times what? Times 3.5, which is equals to what? Which is equals to 12.6 minutes. Then we are getting there. We can change this to WFR5, but I decided to leave it like that. So we are getting there. Now, don't forget where we are going. We are going to what? 1 over bottleneck. And we know in order for us to get the bottleneck, we need to know the WLI ratio, which is WLI over SI. We've obtained the what? The WLM, which is the what? Which is the total operating time for the material handling system. So what else? We just need to find the WLI ratio, and then we'll be able to get our bottleneck. And once we'll be able to get our bottleneck, we can find what the maximum production is. The rest is simple. So now, we've obtained all the what? The WLI. So we need to find the what WLI ratio, because that's where we are going. That will tell us which of the station is the what is the bottleneck. So say this station, but then I will be representing it with 1, 2, 3, 4, 1, 2, 3, 4, 5. Because I've already written it here. Let's say 5 represents what? Material handling what? Material handling system. So for 1, okay, now WLI over SI. For 1, WLI, which is the what? The load and unload station. WLI is what? Is, we got this to be what? 7.0 divided by number of server. Let's now go to the question. That's why I neglect using what? SI for what? In that particular formula the other time. So for the WLI, the number of server for load and unload has been given to be what? When station, go back to the question. Station 1 loads and unload part using 2 servers. It means that's for 2 servers. That is divided by 2. We get the value here. For the 2, which is horizontal mean, we obtain the what? The value to be 8.7. 8.7 divided by the number of server. Let's go back to the question as well. Which is station 1 load and unload, 2 server. Station 2 perform horizontal meaning with 2 servers. Station 2 perform horizontal meaning with 2 or 2 servers. Divided by 2 as well. 3, 4, 5. So we move to what? Station 3. We obtain the value for operating WLI for 3 to be equals to what? To be equals to 11.3 divided by the number of server. The number of server has been given in the question to be what? To be 3. Station 3 perform vertical milling machine with 3 servers divided by 3. So for station 4, which is the what? Drill. Station 4, we obtain the WLI to be what? The WLI to be 13.45 divided by number of server. Number of server has been given in the question to be what as well? Check the question. We have station 4 perform drilling operation with 2 servers too. For station, now for the material handling system. For the material handling system, the formula for finding the WSI, instead of the server here for the material handling system, we have number of carriers, not server. Because the number of carriers is the number, we represent the number of server there, like let me say the robots, the conveyor belts. So these are the carriers. So and they are what? They are 3. That has been given in the question to be 3. Check the question. The flex mobile produce 4 parts this. Okay, this let's check. Okay, so it has been given in the question. Check the part where they said the machines are connected by a plant handling system that has 3 work carriers, which means the SIS is what? Is 3. We are using 3 here. And what we obtain the WLI to be what? To be 12.6. So let's divide them and see what we have. So dividing them, we have this one is 3.5 minutes. This one is 4.35 minutes. This one gives us 3.77 minutes. While this one give us 6.725 minutes, and this one give you 4.2 minutes. Now, let's now ask ourselves questions. Which one is the bottleneck? We said the bottleneck is the one that takes the highest number of time, which is this. You can see this is the highest there, 6.725. So this is the bottleneck. The bottleneck. Of course, we know our bottleneck now. We can find out what the maximum production is. That means the maximum production rate, which is RP, is equals to 1 over what? 6.725. And that gives us what? That gives us 0.1487 production cycle per what? Per minute. That's the unit. Or you can, if you like, you can convert it to what? To hours by multiplying it with what? With 60. So we have the RP now. That's just the number one solution. Then we'll move to number two. Number two question says, utilization of each machine in the system. The utilization of each machine in the system, question B, that is U1 for each machine. For load and unload, U1 equals to the WLI ratio, like I said, times what? Times RP. It's just simple. For product 1, that will be WL1 over S1 times RP. And we know WL1 over S1 to be what? For product 1 to be 3.5. That will be 3.5 times 0.1487. We obtained it to be what? To be 0.552. So, but it must be in percentage. That would be 52%. We multiply it with 100 in order to get this in percentage, 52%. For machine 2, that would be WL2 over S2 times what? Times RP. WL2 over A2, that is WL2 over what? S2. Which is the operating time for for machine 2 over what? Over the number of server, which is 2. So we've got that one to be what? 4.35 times what? Times 0.1487. And that one gives 0.647, which is equals to 64.7%. 68, this will be 68. So say 64.8%. So for U3, that will be WLI of U3 as well. That's WL3 over S3 times what? Times RP. WL3 over A3 there is what? Is 3.77 times RP is 0.14 what? 1487. And that gives us what? That gives us 100%. Is it 100? And that gives us 56. No, that gives us 56.06. That gives us 56 point what? 0.06. 56.06. No, 0.5606, which becomes 56.06%. Okay, for U4, which is the what? The drain. Down WL3, WL4 over S4 times RP as well, right? So the WL4 is what? Is 6.725 times what? Times 0.1487. We should be thinking, we should know what this answer will give us already. Since this is the maximum one, then we are expected to get what? To get 100%. So that will give us 100%. This is the bottleneck. We must get 100%. And for what? For U5, which is the maternal system, that will be WL5 over S5. We can't really call it S5. Let's just say the WLI ratio of that of the maternal system, which is what? Which is get to be what? To be 4.2. To be 4.2. Wait, okay, let's say WL5 over what? Number of carriers. Yes, number of carriers. Let's put that WL5 over what? Number of carriers. Because here we are using number of carriers and not number of server. So that will be, and that will give us 4.2 times 0.1487, which is equals to what? Which is equals to 0.6245, which is equals to 62.45%. And that's all. That's all for number 2. And for the final question, this is question B, continuation of question B. And for the final question, which is what? The average utilization of the what? Of the system. We now want to find the average utilization of the system entirely. That one will be given the formula to be what as well? Summation of what? Summation of SI times what? Times UI over summation of SI. That is the number of server times the utilization of each workstation or machine divided by what? The number of server. That's the formula we use. And how do we do that? You say for products for load and unload, we have the utilization there to be equals to what? 0.52. We are not using the percentage. 0.52. We have it to be equal to 0.52 times what? Times, that's the utilization, okay. The server, the number of server for what? For the number of server for load and unload has been given to God to be 2 times what in the question? Times the WLIH, which is 0.52, then plus that of H mean. H mean, the number of server for H mean was given to be what? To be 2 times what? Times the U2, which is 0.648, plus that of V mean. V mean is what? Vertical meaning. That one is the number of servers being able to be 3, then times the utilization of it, which is 0.5606, plus that of the what? U4, which is drill. The utilization, the number of server is 2 as been given in the question, which is what we use to divide this. All this one, there are number of servers, right? There are number of servers. So 2 times what? Times the U4, that is utilization of what? 100% or 1 is equals to 1 or equals to 100 what? Percent. If you multiply it, so that will be into what? Into 1. All over what? Over number of server. Summation of number of server. For this we have 2. Another one for H mean we have 2. For V mean we have 3. Then for what? For drill we have what? We have 2. Okay, let's solve this up now. And that will be equals to what? Everything, do everything together, and it's equals to 0.6699, which is equals to 66.97%. And that's the average utilization of this thing. You should notice something here, that we did not include what? The utilization of the what? Of the material handling system. This is why we did not include the utilization of the material handling system, is because we are only considering the what? The workstation, the machine, and not the material handling system. The material handling system, we want to know the average utilization. The material handling system is not really playing part on the what? On the material directly. So that's why we need to what? Consider the what? The workstation alone, and not the what? The material handling system. When we are looking for what? The average utilization of the what? Of the what? Of the system, because it is not directly it does not have direct impact on what? On the product being manufactured. But then a question will be thrown to us, which will be displayed on the screen. So we are employed to solve the question. But then I need to explain something quickly for us to, in order for us to get it very well. You can see in the question we are told to find all other steps being the same. Follow the same step and be able to get the what? The A, B. But I want to talk on what? The A, B, and D self. But I want to talk on C. Here in this question, we are not given the what? The number of carriers. We now have to get the what? The WLI. The WLI for the material handling system. This is for the material handling system, which is what? WL for the material handling system, NT times what? Times mu T. So the mu T, we've been given this, and we've been given what? We've been given this, we find this. And we know this is what? We have the formula there, which is what? The workstation in each part times what? Times part mix times what? Times the frequency. We have the frequency. So then with that, we'll be able to get what? To get WLM, which is 16. Try the question and we see what I'm talking about. which is we'll be able to get this. But then it remains the NC, which is the what? The number of carriers. We are not given the number of carriers there. So now let's now take that question C, which says, what is the minimum number of cats, which is the carrier, which are the carriers, in the material handling system required to keep up with the production workstation? One thing we should know there is that we know we have the bottleneck here to be 6.85 minutes. That is, all operations has to wait for this to complete before there will be what? There will be assembly. So all operations has to wait for this to complete before there will be assembly. So which means this, and this has to wait for. This means the maximum time you can have in this production system for the workstation is what? Is the 6.85 minutes. So now say the minimum number of cards, which means in order for us to get the minimum number of carrier or cards, we need to equate what? This 16.0 over NC has to be equal to what? To the 6.85. That will be the minimum you can use. So the maximum can be more than that. Because the maximum, we can consider some material handling system, some extra material handling system, for maybe in case there is breakdown, there can be like 2 more or 3 more. So but for minimum, it is when this is equals to the bottleneck. So now for us to get this, we say 6.85 equals to 16 over NC. Doing that, we see that NC equals to 16 over 6.85, and get it to be equals to 2 point something. I think 2.3 2.34. So you can just round this up to what? To 3 cards. So we need 3 cards for the system to what? To run smoothly. For the system to run smoothly. And the last question there that might be difficult is the question. It says, what recommendation will you take to improve the efficiency and reduce the cost of operating the FMC? What is the recommendation? Let's look at this. This is where we see it. Let's say if this is 2, we know the bottleneck, all this operation has to wait for this to complete, right? So let's say if this is 1, will the time still be more than this? Because all this one, the remaining time for them to reach this, they still have to wait for that particular time. The difference between this and this, they have to wait for that particular time. So this one is 2.5 minutes. So instead of waiting for 2, if we reduce the number of server to 1 here, we have 5.0, which is still not up to this. It means it will still have to wait for like 1.85 minutes. So it means if we reduce the number of server here to be 1, we are still okay. So what about this one? We cannot reduce this one because this is 1 already. We cannot say half, so we cannot reduce this. For this one, it is the maximum one. For this one as well, we can reduce this one to 1. If we reduce this one to 1, we get what? 6.2. And is 6.2 greater than this? No, it's not. It's still not up to 1. So if we reduce the number of server here, we reduce the cost of what? Of getting all those server. So the recommendation we can give them is that what? We reduce the number of server in station 1 to 1, because 2 is not really doing anything. It still has to wait for this part. Then the difference between this and this, the time interval between this and this, it still has to wait for that time. Yes. So we can reduce this one to what? We can reduce this number of server here to 1, and we can reduce the number of server here to what? To 1. That's just it. Thank you for listening.